Today, we're going to talk about processing COVID-19 data with Apache Spark, and we're going to build a full pipeline, including machine learning, to see what we can do. Okay, so let's get started. And this is going to be an exciting new experience for me. So I'd love if you can actually put something in the chat room to see if it actually works. If not, I think I'll survive as well. Okay, so let's get started. So my name is Jean-Georges Perrin. I often go by JG or JGP. I've been in software for a while now, like since 1983, when I was 12, and I started big data in 1984. One of my pet project in 1984 was to actually start to measure traffic lights and things like that back in the day. So there was kind of building a smart city. Of course, needless to say that on my Atari 800 XL that was completely useless. And I've been doing AI since 1994 as part of my college studies, and then in 2010 as part of my startup. I've been an IBM champion for 12 years, something I'm kind of proud of. Recently been partly involved in the La French Tech, and you can join me on Twitter at JGPerrin, or at you can see my blog at jgp.ai. Outside of that, I work at Advanced Auto Parts, which is a really great company to work for, and I'm part of the Digital Garage, so we are experimenting with a lot of new technologies and all that to advance your experience as a motorist. And one of the reasons I'm here is because I've wrote this book, Spark in Action, and of course it's here, Spark in Action. It's pretty well received by the critics so far, so if you want to learn anything about Spark, which we're not going to cover here, I welcome you to have a look at that. And then that's actually where I'm ending any form of advertisement. Anyway, so let's start by what's big data and what we're trying to achieve there. Big data has many definitions. There's the 3 V's, the 4 V's, the 5 V's, but basically whatever you're thinking about big data is often about volume, which is really because it's big, the variety, because it's kind of taking a lot of different shapes, kind of different data coming from different sources, like relational database, files, streaming even, and of course the velocity, which is because it's coming more and more at a faster pace. That's one definition. Another definition I like, and actually I like better, is big data. Data is considered big when it needs more than one computer to be processed. So I'd like to just pause a little bit on this definition here. Why is that important? Why is that an important definition for me? First is because the data, if it's big, and more than one computer, it implies distributed computing. Okay, and we'll touch a little bit on that. It's also because it applies not only to a specific technology. Okay, you can think about databases as that will rely as a cluster of database, and that's not small data. That's already big data. It has the same problematic as big data, but as we're here to talk about Spark, let's look a bit about Spark and define what Spark is. So Apache Spark, I've been using Apache Spark for over 5 years now. So before that episode, and right now I have been. I think that a good definition of Apache Spark is an analytics operating system. You can see on this picture on the left on these photos, my friend Rob Thomas, who wrote the foreword of the book, and at World of Watson, and he was defining Spark as an analytics operating system. I had a trouble really, connecting to this definition, and that's where I started to really trying to understand what was going on there. So as I kind of looked a little bit into that, I wanted to drill down. Okay, so what's an operating system? You've got your hardware layer on top of which you're building, well, you're not building the operating system, but the operating system is relying on your hardware, and you're building your apps based on this operating system, right? You've got hardware. You could have an x86 hardware architecture. Your operating system could be either, for Mac OS still, for a few months, Windows or Linux, okay? And then you will build your application on top of that. The role of the operating system is to shield you from the hardware. But that's easy or comprehensible when you're dealing with simple computers, okay? When you have multiple nodes, how does it work? Okay, you've got multiple hardware, you've got multiple OS, hopefully the same, and then you've got to build your app. But it doesn't really work like that, because you will have to add the distributed layer in your app as well as the analytics layer in your app, okay? And just doing that will make your application fat and error, kind of fat and prone to errors, right? So let's consider something else. You still have your hardware, your nodes, you've got your operating system on top of it, and then on top of that you add a distributed layer, an analytics layer, okay? And this is on top of which you are building your applications. So this is really, for me, what Spark is, what Apache Spark is, these two layers that will shield you from the operating system, from the distributed management of this distributed layer, of this analytics, by providing so much APIs to you so you can build your application easily. So that's really, for me, the key element of what Apache Spark is. And of course, it's also an operating system, as you are not dependent on one language you have to use for doing that. You can use Python, which is really super popular. You can use Scala. Apache Spark is built in Scala. You can use R, or you can use, of course, Java. Which is still one of the most popular, if not the most popular language in the enterprise, with and they share with Python usually. So let's look at who is using Spark. Okay, you've got basically the data engineer and the data scientist. It's important to understand at least the basic of the difference between the two. When you're a data engineer, you're basically building the data, taking the data from one place and making it available so it can be consumed and tested. Okay, so that's why you develop, you build, you test, you operationalize data stores, and whether at small or large scales. Basically, you may have heard the term of data ops, which is kind of the new DevOps, just specifically for data. And you're actually matching the architecture with the business needs, and you improve really the idea of data reliability, in the terms that it's there, and quality as well. And I would point you to you can Google Cactar on the web, and you'll find an article I wrote about data quality. That is really something like, that's the scope typically of the data engineer. The data and scientist on the other side is really about, cleaning, messaging. It's about being very nice and kind of massaging the data, being careful with the data, organizing it, and making sure that you've got the right insight and discovering the hidden gems and patterns that you will find in the data. That's really, of course, you can have more technical tasks like build the predictive models for AIs and things like that. But also, a data scientist is about telling stories. It's about storytelling to the different key stakeholders in the enterprise that needs to understand what's the role of the data and how the data is being used. So, what kind of tools are both using? And you can see that both the data engineers and the data scientists do not use the same tools. Data engineers will use RDBMS or some kind of elastic storage like, Elastic or MongoDB or relational database like Oracle, IBM, DB2, or Informix. You've got also other things like, even Hadoop, it's still there, or GitHub for storing something. That's really kind of in the scope of the data engineer. The data scientist on his side is more about using it more analytics tools like Watson Studio, Cognos, Databricks, SAS, MATLAB, and tools more like towards reporting like Tableau. And two of the very popular tools among data scientists are notebooks, and we're not going to detail that, but Jupyter and Zeppelin are really great examples of what you can find in the data scientist toolbox. Of course, as the data scientist is a storyteller, he will also use tools like PowerPoint or Excel. Okay, but you see this middle ground there where both the data engineer and the data scientist find the same tools. And that's where you've got this really excellent sweet spot for Apache Spark. And of course, SQL, Python, as I mentioned, Scala, and I wish a little bit more Java, but I know that it's mostly on the data engineer side and not really too much into data scientist side. But anyway, as we drill down, I'd like also to go a little bit over an anniversary. Okay, so Spark is 10 years old. So even if it's still in infancy in a lot of different points, it's already pretty mature as an open source project. Okay, 10 years old. That's pretty impressive. And just to look at that, what is interesting is also what is being used as language in the scope if what's going on with Spark right now. Okay, so really what Lawson is that Python is really a very, very popular language and in the use for notebooks. Okay, so in the term that is mostly for data scientists, you see, and that's 68% of every code written in notebooks is actually Python. 18% SQL, and that's really interesting because for various purposes, it's because optimization has been really done on the Python and SQL and benefit actually a lot of the other things. So before I also would like to go a little bit on what's new in Spark version 3. Spark version 3 has been released like really recently. Version 3.0.0 came in June, and 3.0.1 is 1 week old or so. There's been like 3,400 Jira tickets that has been corrected, and you see or added or in terms of new features. So it's a massive new release, and you see here, and you can relate to the graph to the diagram I just showed you before. Spark SQL is vastly have new features there. Spark Core as well. Okay, so that's really the core features for making more SQL more available, more support, and all this is really there. We're not going to go over the 3,400 Jira tickets. That would take days at a pace, at a reasonably like a 1 minute a ticket would take us days just to cover that, and would not be that useful. But I just wanted to show you where the progress have been made and where we're going there. So and also, if you're just a little bit familiar with Spark, you know that there's a lot of static functions which are super useful for your data transformations. Okay, and Spark 3 has added 36 new features, new functions. They are listed there with their Jira ticket associated to them, and you'll find that on Manning's website for free you can download the list of these functions with the explanation of what they're doing. So in a comprehensive manual as well. Okay, so that was a bit of a theory, and I really wanted to drill down a little bit on a program, okay, on an application. And as you probably saw in the title, we are going to talk about ingesting and applying data quality rules on COVID-19 data. So the methodology I'm going to use is really called the AI ladder. It's been inspired by Rob Thomas, and it's really this 4-step process where we are first collecting the data, then we are organizing it, analyzing, and infusing it. Okay, so we're not going to go to the infuse part today, but we're going to collect, organize, and analyze it. And there's always something with ladders. Okay, when you think about ladders, I cannot think about Donkey Kong and just going things and avoid that. And really, it's I think that the climbing the AI ladder is a bit like that as well. Where you've got ambushes and things like that. So it's really about being careful and climbing this ladder, avoiding the pitfalls. Okay. So another way to look at that part is being really careful about our journey with the data itself. Okay. So the first part is we're going to take the data as we find it on the internet. We are going to ingest this data in Apache Spark, and that's going to be our raw data. Okay, that's the data as it's ingested, as it's there. Okay, synonyms for raw data could be staging zone, landing zone, bronze zone, or even the swamp zone in the case of a data lake. And then after that, we are going to apply some data quality rules so that this data can be used in a more efficient way. And to do that, and the pure zone has also some I've got cheat notes, of course, about that. You can call it the refinery, the silver zone, the pond, the sandbox, or the exploration zone. Okay, I like pure. And finally, this pure data we can apply transformation on this pure data, and you get the rich data from that. Okay, and the rich data, you will also find names like production data, gold, refined, the lagoon, or the operationalization zone. Okay, so that's a crazy one. And finally, you're going to publish this data, and you're going to have actionable data. Okay, that's a mouthful. Let's drill a little bit more. And to do these examples, we are going to use Java because, as you can see clearly here, it's a much safer choice, right? Okay, so let's start by collecting the data. I am going to simply get the data from GitHub through an automated process and from the Johns Hopkins Wheeling Schools of Engineering. They put all the data that the Johns Hopkins University has collected worldwide, and they put that in GitHub. Okay, so that's where it starts to be a little bit interesting in terms of data flow. So the data is pretty ugly when we get it. Okay, so and we're going to look at it a little bit more detail. But that's really how the data is. So the first extract here is what I want. Okay, you see in this extract that I want clearly a state. Okay, a column state with a country, with the last update as an ISO date, the number of confirmed cases, the number of deaths, unfortunately recovered, active, and a key that I can use after to build aggregation on, right? And you can see that if I look at what I get for January or what I get for April, this is totally not what I want. Okay, and let's look a little bit more at the data itself, as in this, as I think it's a little bit of life is not completely uninteresting in our situation. Okay, so let's get rid of that. Okay, so here is the website for the Johns Hopkins, and you see that everything is kind of up to date. And I am going to look at Eclipse. Hey, Eclipse, come here. Okay, sorry for that. Okay, and I know it's a little bit small, but this is, for example, the data I was getting for. Let's clear that. The data I was getting for April. So you see that there's a column called FIPS, a column called admin2. Why admin2? That's a mystery. Province underscore state, country underscore region, last update, lat, long underscore, confirmed, etc., and my combined key. Okay, so that's what I got in April. If I look at what I'm looking in February, you see that it's completely different. Okay, look at that. I've got province/date. I've got country/region. Last update. So the column names are completely different, and you see things like mainland China here. Okay, so I will see more in details. When you look at the dates, at the date time here, oh, that's kind of good. The date time is kind of good. It looks like it's really ISO with year, months, day, and the date. But if I look at the very first ones, that's what is that date format? Okay, it's a mix of dates in an American format and our timestamps in European format. So there's all these things where, as you can see, my data is definitely not as clean as I'd like. Okay, so if I look back at my conclusions of analyzing this, I can actually show you what the organization step of the data actually helped me doing. Okay, so first I had to structure and normalize the data. Okay, as I said, dates are sometimes in ISO, sometimes in US, sometimes, as I just showed, a combination of both. China is written ISO China or mainland China. Sorry, that's a typo here. And South Korea has 3 different variants. There's no unique ID for location in the early version of the format. Okay, so if you want to do aggregation per location, no way you can actually do that in a reliable way. And files are, of course, I didn't show you that, but files are, of course, in different encodings, which, as you can imagine, simplifies drastically what we can do with the data. Okay, so the idea is to create our pure data as part of this organization process, and doing that. Okay, so let's have a look at code. Okay, and let's look at code. So let me close that let me close that in our favorite Eclipse here, closing all these things, and sorry that it's a little bit small there. I've been trying to play with the font and have something decent, and I've not been really successful, especially on the left side here. I'm welcoming any tips. So let me close everything here. Sorry, and let's look at that. So the first basic ingestion you could do in Spark is a star, and this is not really working because it's trying to combine everything together. Okay, so let's look at the reflex you would have as without even looking at the data. So as you can see, in my class here, I've got my start method. That's where everything starts. I'm going, you see, to synchronize, just synchronize my repository from GitHub to my working directory for my data. And then I am going to build a session, a Spark session. and after that I am going to just sorry wrong example, sorry. So that's the beauty of life. Okay, so it's a simple data ingestion here. I'm going, I was at a session, you see that's the same thing, and then I am going to ingest, you see here, file names, and I'm going to ingest everything. That would be a very efficient way to ingest all the data in Spark if the data was exactly matching the same format all along. Okay, so that would be the first reflex you can have, and you look at the data and then you find that it's not exactly how I'd like that to be, right? So I had to do a little bit different things and to look at that. Okay, so let's drill a little bit into this. This is not really easy Spark. It's kind of, I would say, advanced Spark. And this is the example where I am going to build my pure data. So if I look at my application here, okay, so very similar. I like to show the imports I'm using. So basically, the data set, the row, and combined they do the data frame. And then we're going to have a Spark session and a bit of logging and a few utilities I have. Okay, so in my main, the only thing I do is I instantiate an instance of my class and do a call start. And start, what does start do? As before, it exactly does the same thing. Create a Spark. Create a Spark session. Okay, you can see here the Spark session, and after that, you can see that I've got a special configuration part, the configuration property here for Spark 3, and creating the session. Okay. After that, I'm just asking Spark to ingest all that. That's it. That's one method to ingest that. Okay, and we're going to drill a little bit into that. If I look at that, at this method here, ingest, so the first thing I'm going to do is sync the repository, and this is really about cloning the repository from GitHub to my local directory. Then I will go through each file, okay, creating creating a list of files that is ending with CSVs. That's my next step. And then from that, I'm going to go through each file and look at it. So what am I going to do? Here, the first thing is I'm creating this instance of a dataset of row. And this instance of dataset of row is a data frame. Okay, so it's still pointing to null for now, but I will need it after. So here I'm going, the first thing I'm doing is I'm extracting the header from the file. One way I noticed is that to determine for me which way to ingest the data was actually to look at the header. Okay, it is different, so I will ingest each file through the different header. And when I'm doing that, I'm actually looking. I'm looking at I'm reading the header. If the header, there's a small caveat as well. You know, there's this first character of the file, which can sometimes be tricky for you and tell you the encoding. Well, then actually, if this is there, I'm actually just going to remove this Unicode character that is actually painful. Okay, so that's what I'm doing here. And then after that, I am going to ask my main ingester to ingest my file based on the header I just detected and store that into an intermediate data frame. So, and that's what I'm doing. Then I'm calling main ingest, and what is done main ingest is simply going through each header, having a case. So for early January, February, March, and April and later. After April, they decided not to change the format anymore. But this is really here's you've got your case here, okay, which based on the header. You've got the case for February and after, and that's what I'm doing. Okay, so if we look in details at the first pass, which is the ingester one, okay, so ingester one, what it's doing is it's actually looking at the schema, okay, and it creates it's not looking at the schema, it's building a custom schema for each file, and for this specific format of file. So I can specify my column name, and I can also specify the type and whether it's required or not. And I'm doing that for state, country, last update, confirmed, death, recovered, active, combined key, incidence rate, and case fatality ratio. Okay, so that's my schema. Then I'm ingesting it. And the order of things is important there. And then you see it. So I'm asking my session, read. The format is a CSV. I'm specifying my schema. Okay, I'm specifying that I have a header. I'm specifying the timestamp format I'm reading in this file. Remember, every file may have a different timestamp format, and then I'm loading that. Okay, and for the missing columns, then I'm actually adding a null value to the column called FIPS and mean latitude and longitude when it does not exist. Okay, and I'm doing that for every format. So you see here that was my format 1. Okay, and sorry, I'm going back to main ingest. Main ingest is there. That was for early January. If I look at what I got in February, for example, and we're not going through all of them. You can do that by yourself. I'm looking at this ingester. So it's the same strategy here. Building a schema. And this schema, I've got actually state, country, etc. So you find the same fields, same, of course, same data types, and you are going to. I'm going to do the same thing here. Here, notice that in this case, I have all the columns already, and all the values, so I don't need to add them null values to those. Okay, so I have. And the same strategy for reading it. See, creating my data frame, asking the Spark session to read a file in format called CSV, specifying a schema, having option, having settings that I have a header. See, I don't have a timestamp here. Spark is smart enough to detect for this the right time format, the timestamp format, and same thing and then I'm loading the file and returning the data frame. Okay, so for different formats, for different ingester. Okay, not rocket science. What I'm also doing is I'm adding a column called ingester. That's what you're seeing here to my data frame, which will tell me which ingester has been used if I want to debug if there's any issue. So here my column called ingester is yeah, Striker PXS saying I'm going to start calling anti-maskers COVID ingesters. Yeah, that's a very smart thing. I should modify my code for that. Thanks for that. Makes my day. And you so the columns here. Columns are either int 1, 2, 3, 4. Okay, nothing complex here. I'm just creating a default just in case there's something wrong or there's a new format coming down the way, and then I'm actually adding a column as well based on the file name, kind of reported date, based on the date in the file itself. Okay, so that's my main ingester. And what am I doing when I'm back to my loop going through each file here, and what am I doing is if I'm the first cases, okay, in this instance of, well, not yet an instance, but this reference to a data frame here, you remember I just did that before, was null. But if it's null, I'm just going to assign that, okay? And if it's not null, then it's a bit like, adding the data. The way to do it with Spark is doing a union by name. So basically, I've got two data frames, and Spark is going to glue them together in a union way, like you would do in a SQL statement. Okay, so it's not, once more, nothing rocket science here, just standard data operating procedures, and I'm going to do that. I'm going to ask Spark to do a union by name. There's two ways to do it. You can do a union, or you can do a union by name. I choose a union by name because I'm not guaranteed that through all these things I'm doing through the ingesters, the columns are in the right order. So that's why union by name will look and will union based on the column names of the data frame. So that's my ingestion. Okay. At the end of that, I've got pretty good, I've got my data in my system in a data frame. I've got a big data frame, and based on this big data frame, I've got all the files. And so if you're if you know a little bit more about Spark or if you started reading the book, you know that inside Spark will create partitions, and in this situation we will have one partition per file, okay, and it has its importance a little bit after. So let's go back a little bit to the slides and move forward on our process. Make sure that I am not forgetting anything. So if I go, here you see the data pipeline, which is a very basic data pipeline. You probably cannot disagree with that. Start a session, then I ingest my data, and then I'm applying data quality rules. We have not seen yet how to do the data quality rules. Here is some code, just the code we went through. Here is the code for the data quality rule. Okay, so I will show the code for the data quality rule here, and then we can also look at the real code itself as well. Okay. So as you can see, it's all on GitHub as well. You can see it's in the github.com/jgparent, and it's net.jgp.books.spark.chapter 99. So it's the same structure as I used for the books, but this is a special chapter called 99, where I'm putting my more advanced, more combined stuff. So if we look here at this ingestion, what you will see is that I'm working with the data frame API. Okay, you see df equal df.repartition.with columns, and that's where I'm going through my different different cases. Okay, remember one of my problem. Korea. Okay, Korea was written sometimes Republic of Korea, sometimes Korea, comma South. So I decided that the way I wanted it is South Korea, and South Korea is going to be that. So the way you read that is, if I've got if I have a column, I create a column that's with column creates a column, and when I've got a rule in my column country equals to Republic of Korea, or my column country equals to Korea, comma South, I'm creating a literal column called with a value of South Korea. Otherwise, I'm just keeping my country column. So this is Java syntax. I know a lot of people are critical about the Java syntax, and you say, oh, with so many parentheses, it looks like Lisp. But actually, it's, I love Java, and you can make fun of me because I like Java, but that's still popular a lot. So anyway, and I'm doing the same. So that was my first rule, and my second rule is about China. Okay, so. And I'm not going political here, okay? So here, same thing. So I've got my country here. I'm looking over my I'm recreating a column called country, and if it contains China, I'm just going to use China, okay? Whether it's mainland China, comma mainland, whatever, I just don't care. If there's China in the name, I'm just going to write China. Finally, my last rule here, my last data quality rule, is to create a unique key, not per record, but a unique key for the geographical area that I want to analyze. Okay, and that's going to be useful if I want to do some aggregation, right? And this is where I created my column called combined key, and if my existing combined key column is null, then I'm going to concatenate a comma, the state and the country. Okay, and why there's why it starts with a comma, it's because when the county is specified for US data, then I can add it's part of this key, but at this stage I know by looking at the data that I don't have the county information. Okay, that's why it starts with a comma. Yeah, that's actually the concat with white space. Actually, I may say something stupid. Actually, yeah, you're going too quickly sometimes. No, it's concat. It's concat with separator. So the separator between the state and country is going to be the comma. Sorry, but I could have done that actually. Okay, and otherwise, if it's not null, then I'm keeping the value. Okay, so the syntax of this when.otherwise and when/otherwise is a bit tricky, and it's it's not super readable. If you're more comfortable with SQL, which I'm obviously not, you can use SQL as well, and it's definitely more readable. But I'm once more a Java guy, and I should probably work more on my SQL. Okay, and then finally, I'm just doing a date column based on the last update column. Okay, so just converting it to a date to make sure that it's seen as a date within Spark. Now, at this stage, I've got pure data. So you've got the interesting thing about having pure data at this point is really that whatever analysis I want to do, I can take this data and it's of good quality. So one good practice you could do here is save this data as a Parquet file, for example, or a CSV file, or putting in a database where other analysts can actually do. It's almost like at this point the job of the data engineer is done. You took the data from one place and it was ugly, different formats and all this thing. You straighten it up, and after that, you make it available. You make it nice. You make it in one word. You make it pure. Okay. So your next step is to analyze that. So that's usually a step where data scientist, but the line is blurry, but the data scientist could actually look at it. Okay, so that's where you're making your coming out as a data scientist. And what we're going to do is going to create an aggregate of the data to have one entry per day. Okay, because we don't know if we have more than one entry per day. Sometimes there's recordings that may say that there's more than one entry per day, and also for one country. Okay, and in our case, we're going to focus on Italy. We're going to create a model, and we're going to use the model to predict. Okay, so let's understand first about a model, and then you'll understand why I'm not a data scientist. Okay, so here is how you use a model. Okay, so you've got your first data set. In our set is a data set in a generic term of the data vocabulary. In our case, it's going to be a data frame. You take this data, you give it to a trainer, and from this trainer you get a model. Okay. Usually what people do is they divide the first data set, and they keep a part of this data set as to do QA, okay, to validate that the model is okay. So usually there's this kind of 70-30% rule, but then you validate that your model is well. And how you do it is really, as you can see in the second step to N, is really taking my data, my second data set, which could be your test data set, and apply the model, and you get predicted data. Okay, so this is the magic of a lot of what's going on with AI and machine learning. Okay, so what does it work and what does it change on our code is really not that much. Okay, so and this is where you can see things going. Okay, so same thing here. I'm creating a session. That's always the same thing with Spark. As we just did in ingester, then purifier, then I'm creating a subset of this data called Italy data frame, and that's where I'm going to build an aggregate based on Italy. Okay, and we're going to look a little bit more at the code in that. And then what I'm doing is I'm saying, hey, build my model based on this data frame, and create this usually based on any model you want, any kind of algorithm you want. Here I used a gradient booster regression model. I thought it would be something that would be useful for there. It's actually not really working, but I think it's creating a model for COVID-19 is not as easy as that, and that's where you see my limits as a data scientist, especially as with such data. But we're going to look at it anyway. And then actually what I can do is just predict it. Okay, so the idea is, here I'm using my model and predict, hey, at day 135 of the pandemic, what was the prediction? At day 140 of the pandemic, what is your prediction? At day 200 of your pandemic, what is your prediction? Okay, and that's really how things are actually working. It's really as easy as that. The tough part is to create a model. Anyway, so let's look a little bit at more code than just these few lines of almost pseudocode here. Okay, so let me back to that. Okay, here, look. So this is lab 310. Okay, so you've got every time. I'm sorry, it's so small here, but every time you look at here, this is lab 210, and this is lab 300. So you've got lab 300 here, and you see that it's actually the build run modifier model app. Okay, in Java. So yeah, you can do machine learning in Java if you were just a skeptical person. Okay, so same thing here. I'm going, my examples are usually same thing. So I've got a bunch of imports. Well, you see vectors that I don't need, so I'm just going to remove it. You see my model. It's part of the regression. It's part of the ML lib. Okay, so that's also something. Spark comes with all these things. Okay, so what I wanted to do is use this gradient booster regression model. It's part of a standard library with Spark. Okay, and I've got same thing as before. See, I had a data set, I had a row, I had a Spark session, and that's it. So if I go in my application, you see same thing as I had before. Phase 1, phase 2. Now I've got my my data quality rules here. Same thing we just saw, and then as I said, we're creating my Italy data frame. Okay, and here let's look at what is behind this function, which is really build an aggregate of the data for Italy. Okay, so it looks like it's ugly, but it's not that ugly. So what I'm looking here is, okay, I'm creating my aggregate data frame, and and when I'm doing that is I'm going to filter based on the country, okay, equal to the country I just gave, which is Italy. I am going to group by reported date. Okay, so I'm making sure that I have one entry per date. Then based on that, I'm going to sum the case, just in case there was multiple entries per day. And then I'm going to collect that as a list. Okay, so my data is going to be nested here. And then I'm going to order by the reported date, and then I am going to filter by confirmed cases when it's greater than 5. Okay, what does that mean? When you look at all the graph, at all of what the CDC and the WHO looked at the data, they said that above, when you've got more than 5 cases, that's where you've got your first day of the pandemic. Okay, so you see that in the debug you will see the first day where confirmed cases were higher or equal than 5, and you'll say the mean date, which is here how I actually got that date. And then I want to have a column where this first date is number 1, second day is number 2, third day number 3, etc., etc. Okay, that's what I'm doing here. So basically I'm numbering date, and I'm also dropping the date that I don't need, like the start date, the ingester, the ingester. I don't need the ingester at that part, and that's a column I'm creating here. Okay, and that's using this function called dateDiff from the reported date to the date I've been working on. Okay, a bit of a mind-boggling thing here, but it's all done. And then this is I'm creating what I'm interested in is not the cumulative numbers of cases, but the new number per days. Okay, and that's how I do it. Okay, so I'm using a window on which I'm ordering by date, and I'm looking on a difference per day by day. And that's how I'm building this data. Yeah, I know it starts to be a little bit abstract, so we can actually look at the data, right? That's probably going to help a little bit. So let me just show you the data. And okay, so this is what the data is start to look like. Okay, so you see the first column you have is a reported date, okay, which is the same as a date. The confirmed cases, the number of deaths, the recovered, the number of active, if it's a value. And you see this day with 1, 2, 3, 4, 5, 6, 7 here. That's really the first 7 days of the pandemic in Italy. And then the number of cases, of new cases. Okay, so you see here the 20, 42, 93, 74, 93, 131. You see that that starts to look like it's going to be exponential, right? Okay, so that's all the data manipulation I did. I could have done that as part of my pure data. So every case that I would be using would look like a little bit like that. That's something you've got to discuss with the data engineer as well, on how the data should be delivered to the data scientist. So, and that's really the code. If I'm looking at the thing here, then I've got my data frame. I agree, it's a little bit of a trick. It's a little bit of tricky. The skills are probably not the most basic one, but it's not. It's also not that complex. Then this is where I'm building my model. Okay, so if I look at the detail of my build model function, here is okay. It's a little bit tricky, but and we're going to look a little bit more into more details at that part, and but it's not that complex. Okay, when you look at to create the model, which of course is a wrong model. Okay, don't use that to say you can replace Fauci at the NIH, but you can see that in this line of code it's not that complex. Okay, so basically what I need is I'm creating a vector, and we're going to look at what a vector is right now. So and it's taking a call when you're doing machine learning. Spark is expecting a column to be called features, and we'll adjust that. And that's just, this code is just about building this data. I'm also, if the data if the data is not present, I'm also asking Spark to to add some data, to add the goal, the max day we are looking at. So that's this first line, and then here is really about creating the model. Okay, so there's still a bit of a data engineering mimics there, but after that, it's really about creating the model. So basically, the model is going to use a label called new. It's going to use the features in features. I'm asking it to do 150 iterations on the data. The last type, which is an argument of an hyperparameter of the GBT, the gradient booster regressor, is this parameter is loss type, and then I'm going to use a sub strategy which is called all. Okay, and that's really that's creating the model, and then I'm telling the model, hey, model, take this data and actually this is just a regressor, and then I tell the regressor fit the data to build a model. That's it. Okay, that's really that's as easy as that. And then and then I can actually start doing predictions. Okay, and that's really where your prediction part is working at. And to do that, the prediction is no, that's not even that. I'm really sorry, guys. That's not the prediction. That's just measuring the quality of your model. Okay, that's a data science. I'm not going to spend too much time on that. I guarantee you I wrote the code, but I guarantee you the model is not right. But here really it's a way to evaluate my regression. Okay, so I've got and I'm evaluating that my regression is working. This part still needs some work, and you may have a little bit of study to do purely on the data science part. Okay, one indicator is a root mean squared error, or RMCE, and that's one way to extract it from my evaluator. Okay, okay, and that's after I can do my prediction. Okay, so I build my model, and then I can do my predictions for 200, 300, 400, 500 days. Okay, so now if I'm doing that, and let's run it, okay, because yeah, I started it. Did I start? Yeah, I started the right one. So we're really going through through all the steps here. Okay, so Spark is creating a session. It's going to ingest all the data. Okay, so that means getting all the data from GitHub, getting all the data locally, applying all the rules we saw, starting to apply the data quality rules to have my pure data in phase 2, and then phase 3, it's about starting the analytics on Italy, and finally building my model, and after doing some prediction. So it's usually a little faster than that, but with the streaming in progress, it slows down a bit the computer. So we'll see what it says. And so we've got a bit of a delay, but if you've got questions, it's a good time to ask, like 5-6 seconds between the broadcast and me seeing anything from you guys. So if you wish, you can definitely ask question while this process is working. Okay, so here it starts. Too late for your questions, guys. Okay, so you see start. It creates the start session, the Spark session, synchronization of the repository with GitHub. I must admit that on this one I cheated. I did it before just to test, and that everything was already up to date. And then it starts to aggregate all the data. It's terribly slow. Sorry, guys. There's nothing else than the streaming process running on this machine, but you don't need a killer machine to make that work. It's pretty fast on my Mac, or I've also been using a K-Focus Linux laptop, and those machines are really fast, which of course you cannot imagine while looking at that. Okay, let's go back to a little bit of to the continuation, and then we'll go back to what's going on there. If my Eclipse wants to be nice with me after, okay? Oh, okay. Oh, see, you just run it and it's going on. So here, what happened here is that, see, that's a sample of the data for Italy. You see that's a data frame show, and what you see here is the date, as I showed you, the number of confirmed cases, and you see that it's really growing, the number of deaths, recovered, active, and the day where we are in the pandemic, and the number of new cases. Okay, and you see things like 0 here, which does make sense. Unfortunately, that it was not measured, or there was a problem, but you see a big boost after, and things like that. Okay, so and you see the feature, and the feature is a vector, and yeah, I use the day as a feature, and you see the data growing. Yeah, sometimes you've got, that's data quality things. You've got some strange values there, but you see that what's going on in Italy in terms of new cases, and you can see that, yeah, the new the second wave seems to be coming also in Italy, with a lot of new cases there at 200th day, which is beginning of September. So it's continuing to work. Now it's going to try to predict based on the data. We're going to do that. We're going to leave in predict, and we're just going to look a bit more at the slides there. So that's a data frame I showed you, and here is an important part as well, is to understand what's this new column is. So really the new column is what we will call the label, and that's I took this illustration from the New York Times on a pretty old one, actually, July 7th, and you can see also the difference, what the features is. Okay, so that's really how you build your data, to prepare it for being used by the regression model. Okay, so that's just a kind of a summary of building the regressor, then building, typo here, sorry, then building the model from the regressor, and then you can actually predict stuff. Okay, so let's just quickly look if Eclipse is finished. Oops, sorry guys. Yep. No, still not. Well, it'll finish before the end of the talk. Okay, so basically, it's always the same adage, right, guys? It's really about, if you've got garbage in, you will get garbage out. Okay, so I cannot emphasize enough on the importance of data quality when you're working on AI or any analytics. And the fun part, you see, my model is kind of clumsy, and really, like, you ask a data engineer to build do the data as a work of a data scientist. Yeah, he can go up to a certain point, but after he fails. But imagine that on top of that, I would just have given garbage data. Yeah, no way we could have done anything interesting there. So that's a bit of of really where I also wanted to go to with you guys. You see this central position where we have Apache Spark. Okay, you've got all your data sources, and Spark is such a great engine for ingestion of all these data sources. Right now we just did files, but we could have done databases, other systems, okay, directly with APIs, streams, and just all this data in Spark, and it can be exploited. Right now, what we've been doing is directly an application directly in Spark, okay, in Java. But I could say that this data, and I mentioned that a little bit, is when I've got data I'm proud of, my pure data, I can actually save this data in something like Data Lake. Having this data in Data Lake will allow me to easily reuse it, and having this data lake very close to Spark makes it super fast and super convenient for me. Okay, then I can export this data and export this data. I can give it to once more the data engineering team so they can do other database, other files, other systems, other streams, and I can of course let this data being exploited by data science and data scientists, and that's typically the use case where you use Jupyter or Zeppelin with notebooks, or you can give it directly to business users, okay, and with a product called Redash, which is also an open source project. And so you see that you are building slowly but surely a new concept in data structure at large, at scale, which is not a data warehouse, which is not a data lake or data swamp. It's something that with Databricks, one of the companies behind Spark, is pushing as the lake house. And this is this new concept all put together that will enable you to have really high quality data and high quality usage of your data. Okay, and for facilitating the usage, you can look at things like MLflow, which once more that's an open source project, and Databricks is behind that. And I'm working on something else which hopefully I can announce soon, that it will also simplify all those operations. It's not going to be called TBA. It's just going to be called. It's something that we will announce. Okay, so that's really that's really a future step. Okay, today we've done a lot of things with Spark, with files. We started experimenting with machine learning, and now we are a step further with this complete almost ecosystem of data operations. So let's just have a quick look. Hey, see, it did it. So if we look at where we were, and we'll look at this if else, okay, a lot there. Okay, so this is, I stopped there. Okay, we've got our data. Oops, sorry, going very fast. Okay, so here you see that my data has been successfully loaded. Okay, and finally here you see that my root mean square error is 443. I don't know if it's good or not. And then I've got the learn regression model. So I'm asking Spark to explain to me, almost like a SQL, when you do a SQL, a select, you want an explain from your engine. That's almost the same thing, where I'm asking Spark to tell me, hey, tell me what is your motivation in your model, okay? And this is all this explanation here. This if else then, all embedded there, and the different prediction, okay? And you see how many there is. This is because because of the complexity of the data we're trying to do. And you see different trees and the different weight it gives to the trees. So this is really where not even the the data scientist, but the senior data scientist will be able to explain to you what really all that means. But it's a really interesting thing and really interesting way to look at the model and the representation of the model. And you see there's a lot of those if then else. So if you see some memes with saying that AI is just a bunch of if then else, yeah, but just try to write that by hand, okay? So there's a lot of those, okay? And finally, you see that the prediction, okay? So I predicted to day 200, and this is 1515. Day 300, it predicts that it's going to be 642. Same thing for days 400 and 500. That's why you see that my model is completely crap. But that was the idea. Okay, so it's about time to wrap up. So if you've got any questions, it's about time to also ask your questions. And let me look. Let me go back to my takeaway slide. And so really, the key takeaway, okay, is Apache Spark can be described as many things: libraries, machine learning, tools for data scientists. But my personal definition, which I stole from my friend Rob Thomas, is that Apache Spark is an operating system. It is an operating system dedicated to analytics. And I think this is the most beautiful definition of it. Apache Spark can actually build very powerful, resilient, secure data pipelines, which can include machine learning. Okay, so it's not about just building ETLs, extract, transform, load. It's about building data pipelines that can be smart. Apache Spark version 3, which is available for production, and it's version 301, is a major update with the number of contributors. There's a lot of patches, as you can see. Well, I should say call that Jira issues, but there's a lot of efforts that went into that. This Apache Spark version 3 is now the foundation for a really rich data ecosystem, and we've seen the different components of that. Python is increasingly popular. That's why I did not use it. It beats Scala. I can't be sad about that. I can't. But it means also that I've got to do more and more Python on my side. And the cornerstone of this of this lakehouse concept is really Apache Spark. And unfortunately, one of the conclusions is that COVID-19 really sucks. And I'm sorry, we've got to go through that. So with that, thank you very much for joining today. I hope I was not too awful, as this was my first streaming, not my first live, but my first streaming with Twitch. So that we'll blame that on the rookie experience with Twitch. If you've got any questions, I'm really happy to share anything. I started also due to the pandemic a vlog, which is called Data Friday. There's a few videos on YouTube. You can see that also on jdp.ai/Data Friday, and we can. The idea behind that is also to be able to chat and have a bit of interaction. So if you're up to it, please join. And yeah, I'll wait there for a few minutes with my friends a bear, and we'll see if you've got any questions. So I guess there's no question. I was super clear, or you're super bored. Do not hesitate to contact me on Twitter, JG Perrin. That's the best way to contact me. You can find me on LinkedIn, but mention that you've listened to the talk. Otherwise, I don't get new friends. And and I'm really happy to help if you've got any questions with Spark. Having said that, have a great evening if it's an evening for you. Have a great morning if it's a morning for you, and hopefully we'll see each other sometime soon. Bye bye, guys.